Hi viewers, welcome to our electrical engineering lectures channel for most interactive sessions of different subjects of electronic and electrical engineering. For the latest updates and videos, don't forget to subscribe and click the like button.
Assalamu alaikum everyone. Today in this lecture of DSP we will be discussing how to take inverse Z transform along with several important properties of Z transform. So whenever we talk about inverse Z transform, it means we are going to convert the system function into impulse response or any given Z transform expression into the time domain expression. So basically the conversion is from complex frequency, that is Z domain, into the time domain. Generally we can categorize the methods of taking inverse Z transform into three broad categories, and they include inspection method, the second one is partial fraction expansion, and the third one is power series expansion. The first one is inspection method. So what does this inspection method mean? It is a very simple method which is used to take inverse Z transform for very simple expressions for which we can directly use Z transform pairs. As an example, let me show you a very simple case that, for example, if we are given a simple Z transform, so how can we take inverse Z transform by using inspection method? So as an example, let us consider we have a Z transform given by x of z is equal to 1 over 1 minus 2 Z inverse. And remember, whenever we are giving Z transform, its ROC must be given along with the Z transform expression. So here let's say the ROC is Z magnitude greater than 2. So as this is a very simple expression, so you can directly use the Z transform pair. And which one Z transform pair? You should know that if the Z transform has this form 1 over 1 minus a Z inverse, so its inverse Z transform will be directly given by an un if the ROC is Z magnitude greater than a. So if the ROC is Z magnitude greater than a magnitude, it means the sequence is right hand side, and therefore it will result in this particular time domain expression. So directly by using this transform pair, we can inspect that in this particular expression simply a is equal to 2. So that is why we will directly have x of n is equal to 2 raised to power n un. So that is simply the Z transform. We haven't done any mathematical calculation, that is why this method is called inspection method. But remember, this method can only be applied whenever we have Z transform expressions for which we can directly use Fourier Z transform pairs. So the second method is partial fraction. Partial fractions. This is the most widely used method to take inverse Z transform, because this method can be used to take inverse Z transform when the Z transform is given in the form of a proper rational function, that is in the form of a numerator and in denominator. So how to proceed with this method? First of all, let us see the general formulation and the general steps that we need to follow. So the step 1 is that we will write x of z in either of the following form. Means we can write Z transform either in this form, the rational form, or we can take z raised to power n and z raised to power m as common, and we can rewrite the expression into this form. So this is the first step. I will show by some examples. And step number 2 is we have to write now x of z in the factored form. So we will need to make factors both in the numerator and in the denominator. We can also proceed with the factors in Z inverse form, but I will recommend to use a Z instead of Z inverse. This will simplify many calculations. So once we have this rational form in this factored representation, then step number 3 will be we will divide x of z by simply z. So we will end up with an expression which will be x of z divided by z. Now once we have got x of z divided by z, then we will perform partial fractions to compute all the partial fraction coefficients, and denominators should be in first order factored form. These are some conditions. So these 4 steps will result in the time domain expression x of n. So how to apply these 4 steps? Let us proceed with an example which is given over here. Let us solve this example in the notes. So first of all, let me reproduce the same example over here. X of z can be written as, which is actually given to us in this particular example, it is 1 over 1 minus 1 over 4 z inverse into 1 minus 1 by 2 z inverse, and ROC is z magnitude greater than 1 by 2, right? So this is the given z transform. Now how will we proceed? First of all, we need to convert these powers from z inverse to z, because the given x of z is already in the factored form. So basically both the steps 1 and 2 are skipped, and we directly convert it into the positive powers of z. For this step we need to take z inverse common from the denominator, and we end up with this expression, which is z minus 1 by 4 into z minus 1 by 2. So now we have got this expression. So this was actually step number 2, and now we can proceed towards step number 3 directly, which was we need to divide x of z by z. So the next step is divide x of z by z. So this step will result x of z divided by z on both sides. So we will have this z over z minus 1 by 4 into z minus 1 by 2 with the same ROC, which was z magnitude greater than 1 by 2. So this was the step number 3. Now for step number 4, we need to actually formulate the partial fraction representation of the same form which we have obtained in this step. So x of z divided by z, this will be the same thing which is written in the previous step, z minus 1 by 4 into z minus 1 by 2. Because it is second order, so we can represent it in the partial fraction as a over z minus 1 by 4 plus b over z minus 1 by 2. Now as a normal partial fraction method proceeds, we divide both sides by denominator of left hand side to get z is equal to a. Here z minus 1 by 4 will be cancelled out, so we are only left with z minus 1 by 2 plus b times z minus 1 by 4. Now we will need to put the solutions of the denominator. So we have got 2 solutions over here. The first one is z is equal to 1 by 4. So by putting, let us number this equation by 1. So z is equal to 1 by 4 in equation 1 ends up in this thing. It is, sorry, equation number 2. Let's make equation 2. So it will become 1 by 4 is equal to a. It will be 1 by 4 minus 1 by 2, and this factor will be 0. Here we will get minus a into 1 by 4. So by cancelling out, it is simply found that a equal to minus 1. Now put the second factor, which is z is equal to 1 by 2 in same equation 2, and now we get 1 by 2 equals, now this time this factor will be 0, the first one, plus b into 1 by 2 minus 1 by 4, and this will result as 1 by 4 times b. So here b will be equal to 2. So by solving the partial fraction expression, we have got b is equal to 2 and a is equal to minus 1. So now we put these two values, this one and this one, into equation 1. So from 1, what we get now, we get x of z remember this was not x of z, it was x of z divided by z. So it will be in place of a we will write -1 over z minus 1 by 4 plus 2 in place of b divided by z minus 1 by 2. Right, so now this was the additional z which we multiply it in the previous step. So now to balance out, we again multiply by z on both sides. To get x of z equals minus z divided by z minus 1 by 4 plus 2 times z divided by z minus 1 by 2. And we will write it in a more familiar form by taking z as common. So I can write it, the same expression as -1 over 1 minus 1 by 4 z inverse plus 2 divided by 1 minus 1 by 2 z inverse. Now these are the two expressions which are very familiar with which we must be familiar with the z transform pairs, this one and this one. So now we can apply directly the inspection method to write the first one as minus sign is separate, so it will be minus 1 over 4 n un plus here 2 is extra, so we will write 2 to 1 by 2 raised to power n u of n. Now see, to write this as inspection method we need to know that what is the ROC, because this is very important thing, because if I have written it in this form, it must be assumed that both the poles 1 by 4 and 1 by 2 they are right hand sided. So we need to check the ROC which was given to us in the expression of x of z. So if we go upwards and see, this was the ROC, and this ROC means it is outward from the outermost pole which is 1 by 2. It means 1 by 2 pole is right sided, and also 1 by 4 pole is also need to be right sided. So due to this reason we have found out that both the poles that is 1 by 2 and 1 by 4 are right sided. Due to this reason we have written this expression. Let's say if the case was different, for the same x of z, if ROC was like this, z magnitude less than 1 by 2 and greater than 1 by 4, it would have mean that this 1 by 4 was right sided and this 1 by 2 was left sided, because it is inside 1 by 2. So in that particular case, the same inverse z transform from this equation we directly come over here, assuming that 1 by 4 pole is right sided and 1 by 2 is left sided. Now what would have been the answer? The answer would have been, because 1 by 4 is right sided, so the first part will be same, it is 1 by 4 n un, and in second part we need to place an extra negative sign, -2 and 1 by 2 raised to power n u of minus n minus 1. So resulting in this one left hand sided sequence and this one as right handed sided sequence. So you see, depending upon the given ROC, we can end up in two different kinds of time domain sequences. So that is why the knowledge of ROC is very, very important whenever we are going to find out inverse Z transform, right? So now we take another example, and the reason for describing this example I will tell you shortly.